piecewise functions. Big word. Hopefully it's not too confusing for you. Starting this off, just a general idea. We have functions with more than one function in them. All right, and the things that you will be doing with these piecewise functions is you will evaluate them, you will graph them, and hopefully you will be able to write a piecewise function. Okay? All right, vocab. What is a piecewise function? It is a function that has two or more rules, equations. Let's maybe put the word equations here. That would probably be the most easiest to think about. And the big question is going to be like, which equation do I use if I have two or more? And I'll give you the secret to that. First of all, our first example is an evaluating function. We're going to evaluate 2 and -3 in the function f of x. As you can see, we have two different things on the right side. Yeah, and you've got to make a decision. Which way do I go? Do I go up or down? And to do that, make that decision, you need to look over here, because this is what's going to tell you which piece to use. This first one will say, for example, x is less than or equal to -1. And this will be used, the second one, if x is greater than -1. This value here will always be identical, and it's kind of the dividing value between the two functions, the domain values. All right, so our evaluation at 2 of f, again, I look at my functions and I see that this one is false. I should not use that equation for 2. Instead, I should go down to here because x value is greater than -1. So I'm going to take 4 times 2 and get 8. There you go. I've evaluated it for 2. Now I evaluate it for -3. And again, -3 is less than -1. So we're going to go up to that top equation, and the top equation says 2 minus x. So we'll do 2 minus double negative here. All right, that means an addition problem, so 2 plus 3 is 5. All right, so that's evaluation. You look at which value you're given, 2 or 3, look to see which one you need to plug it into. All right, second example. We are going to graph a function. This function's name is g. It has two parts again. The first part, -x plus 3, is for values that are less than 1, and the second one will be for values that are greater than or equal to 1. Now, important thing when you come to your table to build this, and I strongly recommend using tables initially, I think it's the easy way in, we're going to have, oddly enough, two different 1 values. And that's because 1 is my domain value that kind of splits my function up. Now, only one of these domain values is the one that we're going to use. And as you can guess, we're going to use this one here. This will be the real point that I graph, not the one to the left. But we need them both for references on the graph. All right. The other domain values that we should pick here now are 2 and 3. And then we're going to go down from 1 and pick the next 2 lowest values. All right, plugging them in. Plugging in -1, again, into the top equation. I get -1 plus 3. And I believe that that is going to be 1 plus 3, which is 4. -0 plus 3 is just 3. And -1 plus 3 is 2. All right, I now come to the second equation because I now have a value which is greater than or equal to 1. And we plug 1 into here now, and we get 2 minus 1, 2 times 1 minus 1, I think I get a value of 1. Yeah? And again, we got to remember that's the one we're going to use. We're actually not going to use this, but I need that other one there for reference sake. Take the 2, plug it in. 2 times 2 minus 1, I get 3. 3 times 2 minus 1, I get 6 minus 1 is 5. All right, now we come over to the graph paper. Go ahead and slap down an x-axis and a y-axis. This time I'm going to label them x and g of x, because that's the name of our function. And so we plug in the values. -1 generates 4, 0 generates 3, 1 creates 2, and remember that value there is actually not a dot. We actually need to put an open dot there because that's actually going to be a false point, so to speak. Then I come to 1, 1, put a dot there, 2, 3 there, and 3, 5 there. All right, this looks like a crazy graph. Hopefully you can see what's going on though. To the right of 1, the graph is going upwards in this direction. Yes? To the left, we can see that we started here and we head off in this direction. Okay? So the graph always has these funky two parts to it. Sometimes they're connected, sometimes they're not. Last example. You are going to write a piecewise function for this one that I have drawn below. I think the easiest way out of this is to either identify a slope and a point, or a slope and a y-intercept. In this case, we see the y-intercept really clearly, and the slope hopefully is not too difficult to spot as well. All right, the slope in the first problem. It looks like we are, sorry, I didn't have that quite arranged. Let me fix this momentarily. Nope, that's not working. Hold on. Hold a moment. Okay. We're going to go ahead and use it. No, we're not. We got to fix it. All right. All right, here we go. This is what I meant to have drawn. And then from here, going down in this direction. Oops, made a mistake there too. Sorry, apologies. All right, first one, our slope. I better change my color here. You can see the slope is, it goes from that dot to that dot. You can see it goes down 1 for every 3. The y-intercept, where does it cross the y-axis, is 2. On the second part of the graph, we see that we have a slope of going up 2 over 1, and again the y-intercept is -1. All right, I'm going to take these two pieces of information over to a function. You get to pick a letter, F, G. Let's go ahead, okay, G it is, since I labeled my axis with a G. And now I need to show two different equations. The first equation says -1/3 x plus 2. And the second equation is going to say 2x plus -1. And then we need to state here, where is this graph divided? At what value does it switch? In this case, we can clearly see that it's at 0 when x is greater than or equal to 0, that the graph goes to the right, yes? And x is less than 0 when we go to the left, and we have the slope of 2 and the -1. All right, hopefully that makes sense. You are again graphing, evaluating, and writing functions of piecewise.